a short introduction and then we are good to go. Hello everyone and welcome to Formula Bharat Driverless Vehicle Workshop 2023. The topic for today's session is Advanced Data Analytics and AI/ML to enable real-time digital twins hosted by Altair. The topic is presented by Sandeep Yadav and Rohit Munda. All participants are requested to know the following general instructions. We encourage you to turn on your video during the session. Please mute your microphone throughout the session unless you are asked or otherwise and during the doubt solving session. So without further ado, let's begin with the session. Over to you, Sandeep.
Okay, thanks, Ishita. Let me just share my screen. Hope my screen is visible.
No, not yet, Sandeep.
Not yet. Strange. Sure. Yeah. Now.
Yeah, it's visible.
Okay. Thanks.
Okay.
Hi. Good morning, all. So let's start with today's session. So in continuation with the sessions, what we are doing. So today's session is specifically on data analytics and AI with Altair Rapid Miner. Right? I'm Sandeep Yadav, Regional Technical Manager for Data Analytics and AI at Altair India. And along with me is Rohit, is a data scientist from our team. And just before we start, just a quick introduction. I'm with Altair from last almost a decade now. Having 16 plus years of experience into technology services in the area of computation science, data science, optimization. I'm master's in manufacturing automation with postgraduate in data science, and I'm basically handling all the initiatives for data analytics and AI for India region and specifically for automotive for Asia Pacific region. Along with me is Rohit, so again data scientist from our group. He is masters in mathematics and computing from IIT Dhanbad, and he's again working with Altair now almost close to a year now. He's again working with our AI/ML products, Altair products, and enabling our customers to utilize these products in their product life cycle. Right. So this will be the agenda for today's session. We'll start with the overview of the platform, the data analytics and AI platform, the digital twin solutions what Altair have. Then we'll talk about some of the applications, some of the industry references. Then I'll hand over to Rohit, who will do a live demonstration on Rapid Miner. We'll pick up a one case and we'll give you a practical demonstration with that, right? Then what I'll do is I'll give you an overview of the learning and upskilling platform, because after the session, obviously you'll try to learn this platform and how you can utilize for your applications. So I'll give you an overview of the platform, how you can upskill yourself, right? And towards the end, we'll be open for the question and answer sessions, right? So a few housekeeping rules. You can just, if any questions are there, you can just post in the chat window, right? Or maybe during at the end of the session, you can raise your questions. You can ask your questions, right? So let's start with today's session. And before we start, let's set the context here and what we are seeing, nowadays, how the products are getting evolved over the years, what we have seen. Now we have seen or we may must have memories with this vehicle, right? So this was say one of the cult vehicle of earlier days, Bajaj Chetak, right? And the products have transitioned, have improvised a lot, right? So this is the new version of Bajaj Chetak, as you see, right? They have both, the two wheels, same sort of I would say shape, but what have changed is a lot of changes have gone inside of this vehicle, right? And we see a lot of advancement that have gone, a lot of new technologies that are embedded into this vehicle now. Earlier, this vehicle was marketed more of pure on the mechanical aspect, what kind of engine it have, what kind of suspensions it have, right, what kind of brakes, how much power. But if you see how the vehicle of today, their position, it's just like, they're trying to sell a mobile phone, right? It's Bluetooth enabled, over the air update, geofencing, temper alert, right, connected. So a lot of these advancements. So what we see is a lot of technologies are coming into the vehicle now, right? Apart from just purely being mechanical, a lot of electronics, software controls that are built in now our vehicles. So that's why we can say convergence of these technologies is obviously driving this innovation in our products that's happening nowadays, right? So if we see this transition, how it has happened and still happening. Earlier, it used to be more of a just a product, point A to point B, sort of a mobility vehicle. Then, the whole concept of EV came into picture. The ICE engines being replaced by E motors, right? Then came more of a smart product where a lot of analytics I can see, on my vehicle, right? Then we later, it got further enhanced with connected. So it starts getting connected with external devices as well. So we can say it's a smart and connected product, right? And then when we had lot of these smart connected vehicles on the road, then it builds a complete ecosystem, right? So various vehicle equipment systems that are there, right from safety system to navigation system to, various productivity systems that are built into the vehicle, right? And this whole ecosystems basically is not only the individual vehicle, but how it communicates with other vehicles or its surrounding, right? That all into comes into picture. So that's how this whole product ecosystem is now getting developed. And it's all because of various technologies, the convergence is happening. Now we can build in a lot of technologies in the same vehicle, right? So as a student, as a new engineers, what we should also be aware of how these things are, kind of changing in the industry, right? So every industry is going through this transition. There is a global evolution towards smart and connected. Everything, right from the vehicle, the end product, to the how they are manufactured on the manufacturing line. Even the machines are now smart and connected, right? A lot of mechatronics functions are there into the vehicle now. There is a race in organizations to adopt AI, digital twin in key areas across their product life cycle, right? And we can see going forward, more and more of operational decisions, design decisions will be based on these simulation and data driven models, or you can say digital twins, right? That's why these lot of initiatives are running across these organizations. And we being at Altair, we have the technologies which can handle simulation, which can handle AI, data analytics, and that's how this whole convergence is coming into picture. And you can build all those intelligent models, digital twins, to predict and optimize the system outcomes, right? So this is the vision on which we work with our various products. So giving you a overview of the products that we have, and we are going to talk about one of the product line today. So we have a simulation product line, that is HyperWorks. where you can do simulations, physics-based simulations. You can do optimizations. You can do multidisciplinary system simulation, which I think if you have attended the last session last Friday, which was specifically on Altair Activate and to do these system simulation. And this is the main framework on which you can build your physics digital twins, right? Then you can do data analysis and visualization. So this is our HyperWorks product line. Then this is what we are going to discuss today. So we have a data analytics and AI platform called Rapid Miner, where you can do data preparation. So whenever you have the data coming from your any streaming devices, any of your IoT systems, any of your equipments or vehicles, right? Or cloud, you get the data. If the data requires certain preparation, you do prepare the data and you use the data for downstream analytics, be it building your machine learning model for predictive analytics, or be it just real time visualization for monitoring purpose, right? Then we do have another product line which is purely cloud native. It's IoT platform. We're not going to discuss much on this today, but this is for the IoT cloud native platform where you can connect to various IoT devices, product systems, and you can do analytics and you can build certain nice applications for those. Right? So these are the three major product lines. And now what you see on the extreme right, the vertical stack here, this is what digital twin. So digital twin is not a particular product or a software, it's a solution, right? So if you understand, digital twin is basically a digital replica of any physical asset, right? So to build a digital replica, it could be purely based on data, which we can call it as a data twin, data driven twin, or it could be based on physics, right? A simulation based twin. We can call it as a physics twin or a virtual twin, right? Now, to build these digital twins, you need technologies from these various, say, product lines. So you need to connect to the devices, you need certain products, you need to do data analytics, you need to, for certain complex phenomena, you need to do certain simulations. So you can get, the technologies from here. So that's how using these technologies from various of Altair's product line, you can build a digital twin, right? So I would say digital twin and AI they go hand in hand very much, right? And it will not be wrong to say that AI/ML is one of the key enabling technologies for digital twins, right? So because the digital twin, you need data to create those, digital or virtual twins. The data may come from your actual vehicle, from the sensor, or it may come from the simulations, virtual simulations, right? But definitely you need to build a AI/ML layer to build those twins. Right? Now, these twins, if we try to map, because obviously practically we have to understand where all we can apply these. Right? In an industry, people are applying these digital twins across the product life cycles. Right? Be it at the design stage when your products are in development, right? They're building certain predictive models. They're using AI in system simulations, in testing, right? People are building digital twins for manufacturing, for predictive maintenance for their machines and equipments, quality assurance, yield optimization, and even digital twin for when your products are manufactured and they are on the road actually in service, right? When they are actually operating on the roads, right? And you want to continuously, because these vehicles nowadays are heavily sensorized, a lot of data, real-time data gets streamed from these vehicles. So I want to monitor the health, maybe find out the remaining useful life of the batteries that are out there in these vehicles, or maybe warranty analytics, or maybe just customer analytics. Right? So there are various areas where people are applying. Right? So you can see across the product life cycle, these this can be employed. Right? And obviously, the motive for these twins is I want to analyze or optimize my product performance. I want to manage my product, right? And to get insight into when it may fail, right? And obviously to improve its product life, right? But all countermeasures I can take. Now, if we try to understand visually these different type of twins, digital twins that may exist, right? Uh, I have spoken about physics twins, data driven twins, right? So physics twins, what is on the left side, or physics driven twins, these are purely based on simulations, right? So you do set up your virtual simulations, right? That is sort of a virtual replica or a twin for your physical product, right? But as we are saying nowadays, the products have a lot of technologies that are built in. It's not purely a mechanical or mechanism simulations, right? It have electronics, control, software. So you need a multidisciplinary environment to simulate or to completely analyze the performance there, right? So that's why you need a multidisciplinary system simulation environment to basically build this complete twin. And that's what we showed in our last session on Friday, which Manoj taken for the students. So we demonstrate on this product. I'll touch upon again very briefly on this, just to refresh this part. Then on the right, what you see is the physical asset, where you have your actual product, which have a lot of sensors, a lot of data acquisition system, and the data is being captured, and then you are analyzing that data, and with that data you try to build certain models, right? That could be your data driven twins. So they can work individually. You can just purely have these physics driven twins, and you can purely have these data driven twins, right? But the good part is, or otherwise, let's understand from a vehicle perspective, which you can relate better, right? So maybe I have modeled a full vehicle here, right? So I modeled a full electric vehicle here, right? And with various its components like motor, driveline, and all, I'm inputting a driving cycle and a driver behavior, and I'm analyzing what could be the battery, the voltage or range, battery SOC, SOH. This is what I'm analyzing, right? So this is purely my physics based twin, where various multidisciplinary systems I have built into a single model, right? This could be a low fidelity model I'm simulating here, but this is what I'm analyzing. Now on the extreme right, what you see is actual vehicle which is running, which are a lot of sensors which are there, and I'm basically getting the data from those sensors, and then I'm analyzing that, right? I'm analyzing basically the performance there, right? And I'm seeing how various system of the vehicles are performing, right? Maybe I can have certain predictive machine learning models also deployed here, which can predict when the failure may happen, okay, or what is the life of the battery that is left, all those things, right? So this is purely based on data. I'm not doing any simulations here. So these two twins can work individually as well, right? But the gap is because we want to continuously improve our products, right? We want to continuously improve our products, and what we are doing here on the left side is we are testing, developing our products based on certain assumed drive cycles, right? Certain standard drive cycles. But maybe my vehicle is being run or being tested on a different sort of driving cycle, which I'm not taking care of that part, right? So what can be done is there could be a connectivity also that can be established, right? So this I can call it as a one total twin, right? Where I can have operational data also fetched in, like what, suppose for this case, what is the actual drive cycle? I can get that. I can push into the actual my simulation mode, right? And I can see how it is performing, what kind of say matrices I'm getting here, what kind of responses I'm getting here, right? And are they matching with the actual vehicle, right? If they're not matching, obviously there is certain issues with my this virtual model. I can calibrate my this virtual model that so that it starts mimicking exactly like my physical vehicle, right? So once it start mimicking, then I can say this is a virtual twin or a virtual replica of my physical system. Now what I can do is I can do a lot of studies onto this virtual model, right? Maybe I can calculate certain more attributes as well, which I'm not able to get from here from physical vehicle. Maybe I don't have a sensor there at that particular part, so I can maybe get certain attributes calculated from my simulation model as well, right? I can optimize certain parameters as well, and based on this my study, I can take countermeasures or do some design changes, recommend some changes on the physical vehicle side, right? So this way it can work, right? And to to perform this sort of a study, definitely you need certain technologies which are very much there, even with Altair licenses. So what you see on the right, you need certain machine learning, data analytics product. So definitely those are there, which rapid miner, which we are going to discuss today. On the left side, obviously you need certain simulation, reduced order modeling uh, technologies. Simulation, it could be low fidelity like 0D, 1D, or high fidelity like a 3D simulation. So this also we shown in last session using Altair Activate, right? So these products are there. So this is how you can think of a complete digital twin. So just to rephrase, you can have simply a standalone physics driven twin, you can have a data driven twin, or you can have a complete twin as well, right? Now, as I said, physics driven twin we already covered in our previous session, which was done on 1st of September. The session was the integrated system of system simulations connecting 0D, 1D, and 3D co-simulations, right? So this was done in that session, but let me just give you a brief background or a quick refresher for that. So as I said, physics-driven twin, you can build in multidisciplinary systems into a single environment. So this is Altair Activate, which is a single system simulation platform. I can build in my full vehicle, right? So which can help in development, validation, performance simulations for my complete mechatronics, product development and multi-physics simulations, right? So you have, say, suppose your electric vehicle virtual twin developed here with all these systems built in. So these systems are built in. So there is a library within Activate of various physics-based systems, signal-based systems, which you can just drag and drop, build your system. You can build your some custom math models as well. Build your say full vehicle here, which can help you uh, for doing a complete vehicle level system simulations for drive cycle evaluation, range calculation, right? And this is what I was showing to you, right? So this is the complete vehicle, and when I run this full system simulation, the drive cycle evaluation, right, I can get a lot of performance attributes calculated from this system simulation. So this is sort of a virtual twin of my vehicle, right? So this is done with Altair Activate. Now with Altair Activate, as you have seen, what all we have done, we could do multi-domain analysis, including multi-domain systems like motor, battery, which are like say electrical. There are certain mechanical systems also. So we can do multi-domain analysis. Even you can bring in certain AI as well. So say suppose for the battery part, I want to instead of battery, the battery part I want to replace with the AI model, which behaves similar like a battery. So that can also be done, right? So I can bring in certain reduced order model, which could be AI based as well, to do that simulation, right? And then run this complete functional, system simulations, optimize the system performance and all, right? So the products that can help you to enable these sort of physics twins uh, from Altair side. So the products are the mainly I would say is Activate, which is the main product where you can do all multidisciplinary system simulations, 0D, 1D, 3D. But you do have certain other products as well, like Compose, which is for math calculation, scripting, data analysis. You have Embed, which is also very essential tool which you should be using for embedded system developments. Also, we have a session planned on this as well. Then we have PSIM for power electronics. We have Motion Solve for multi-body system simulations. Right. So these are different products that are there. Right. But Activate would be the main environment in which you'll be building these uh, physics twin models. Right. Going little detail into Activate, just one slide so that it, it is a quick refresher for you. So within Activate, you have all these uh, building blocks that are available right from 0D. Although scripting language support is there, you have the library of signal blocks which you can drag and drop. You have physical components like magnetic components, interfaces block, electrical components. You have electric and electronics uh, ready to use components like resistors, transistors, and all those things. Uh, you can build certain integrated AI models within Activate using your data. The data could be coming from actual tests or simulations. So you can use the data to build some AI models which can be used as a block, a ready to use block. Right. Then even from Activate, you can drive in the backend some 3D simulations as well, right? Be it say mechanism simulations or electromagnetic simulations. Then any third party simulations also you can import as FMUs. Say you are doing some simulation in some other softwares. So you can export FMUs, which are functional mockup units. Uh, you can export from there and import within Activate to use them. Then another essential part is connectivity, because we are talking about a complete twin as well. When this Activate should connect to the actual data as well. So there are some real-time connectivity blocks like MQTT, serial port, TCP/IP. So these different connectivity blocks are there, which can help you to establish that connectivity, right? So using this all things, you can do all sort of a 1D signal-based modeling or physical modeling, circuit modeling, or even AI model generations, reduced order model AI generations, right? And with this, you can do all sort of simulations as well, which can help you in embedded system development as well, like model in loop, software in loop, processor in loop, or hardware in loop simulations as well, right? So this is Activate. I just wanted to give you a quick refresh from the past, the earlier session. Right. Now, if you see one of the customer, Altair customers, so you must have seen these switch electric buses nowadays, running in Bangalore, Delhi, and various other cities, right? So the switch mobility, they used our Activate platform to predict the electric vehicle range with intelligent digital twin what they modeled, right? So these particular digital twins, they can help them to accurately predict what could be the vehicle range, that could be there for this vehicle, or SOC, state of charge of the batteries and state of health of the batteries. Right? So this is what was done by switch mobility. Yeah. So this all was on the physics driven twin, for which I recommend the Activate, Altair Activate is a platform to work upon. Now we'll start with the data driven part, where we'll take more time. We'll do a live demonstration as well, right? So data driven twin, here everything will be based on purely on data, the data that will be coming from the vehicle itself, or maybe sensors and all, right? And this also is driven with what all the changes we have been seeing, the paradigm shift that has been happening. over the years. Right. Earlier, if you see, there was more focus on experimental when people started with all those engineering tasks. Right. Then people shifted on more on the theoretical mode. They developed certain models, certain generalization approaches, and all. Third paradigm, which we can say is still happening also, a lot of computational thing came into picture. Computation, simulating certain complex phenomena. Simulation is uh, a part of this, right? The CAE, the physics simulations, what you do, right? But nowadays, what we can say, we are here, right? The fourth paradigm shift that is happening, which is more of data intensive, lot of data what we have generated over the years. Now we want to explore the data, we want to use the data, right? So this we can call it more of a, nowadays what we are doing is data or AI assisted engineering. So we are getting help from the data to make our decisions. Right? We analyze, scrutinize the data to basically uh, get to our decisions what we want to do. Now, we being engineers, I hope mostly of you, because you are working on development of these vehicles, right? Uh, so we are engineers, and now we have to basically work on data science as well, right? Uh, to do all these analytics. Right? But there could be a challenge here, right? With some of us. So when you start working on these data science tasks, what is expected from you is that you should have knowledge of math and stats. We can say obviously, yeah, we are engineers. We have studied some of these topics, so we do have know-how of math and statistics. Uh, it is expected you have domain and business knowledge as well. So that also we can say yes, we have done domain study, so we do have that knowledge as well. But maybe with some of us, like purely which are known, I would say CSIT sort of a branches, like maybe mechanical, automotive, aero, right? So there, we are not that strong into, say, the computer science or the coding part of it, right? So we may say like, okay, if for data science we need knowledge of these three aspects, we may have some gap here, right? But nowadays, what's happening is we can say that this is not mandatory to know the coding part as well. So there are certain platforms which we can call them as low code, no code platforms, or you can say practical AI tools or self service AI tools. There are a lot of terms floating around, right? So where you need not to have any coding know how, but still you can start with data science, right? And Altair Rapid Miner is one of those products which is purely low code, no code, without any coding know how. You can start working with this product, and with minimal, I would say, training, learning. You can upgrade yourself, upskill yourself from being purely sort of uh, pure engineers to more of a data science enabled engineers, right? And a lot of the term, another term which is floating around nowadays is citizen data scientists. So citizen data scientists are the guys with the domain knowledge, but again with a flavor of data science, right? So they know the data science part as well. So you being the engineer, the domain people, you can upskill yourself with this data science, and you can also become more of a citizen data scientist, right? What you can do with this is, so when you have your, say, just a scenario, so you have your vehicles, you have a lot of sensors in your vehicles, the data is coming in. So you want to study that data, you want to analyze that data. So you have platform for Altair under Rapid Manner, where you can do all sort of analytics. You can understand the data that is coming from the vehicle, see how your vehicle is being used, how that system is performing. Okay, what could be the issues? Okay, how it is operating in various regions, how the difference the performances in various regions. All those things I can understand, right? And on top of that, purely after analyzing the data, even I can build certain intelligent models based on my historical data. which I have from say past 1 or 2 years or few years from various vehicles. I can build certain intelligent AI ML models which can help me in predicting when certain critical components may fail, right? Or how I can optimize certain systems, right? All those studies I can do, right? Then, right? So this scenario I've shown you, right? Now, also there is another aspect of, so there are various vehicles that are there, like a fleet of vehicles. I want to analyze, I want to get real time visibility into the vehicle and the driver performance, the productivity, what kind of driving behavior is following, right? So all those sort of scenarios I can test as well, right? Now for this, what we are going to talk about is the data, purely the data driven part here. And for this, what you need or what the workflow could be, so you have data coming in from various sources, right? So it could be purely like static files like CSV and all, or it could be IoT data, uh, real-time streaming data, sensor data. It could be certain ODBC files, XML files, right? You get data from different sources. You prepare the data if it's required, uh, do certain data engineering, feature engineering part. Then you start analyzing the data, right? So analyze the data and you see, understand the performance, monitor the performance, right? You are not building any intelligent model as of now. You're just purely seeing what's happening, right? Then maybe you can build certain intelligent models as well using AIML, which I was mentioning, right? Using your past historical data, which can help you to get more insights, so in the problems, predict the failures or future behavior, right? All those scenarios basically I can do. So this is how the workflow could be. And the platform from Altair, like we had Altair Activate there for physics twins, for data driven modeling, what we have is Rapid Miner, right? So Rapid Miner is a complete uh, umbrella of products. There are a suite of products, out of which the Rapid Miner is the main product where you can do most of your tasks or maybe all of your tasks. Then for certain specific needs, we do have certain other products as well, right? So uh, first of all, the data part, as I said, you can access the data from various sources, right? Be it any of these sources or real-time streaming data sources, and you can start analyzing your data and start building your models as well, right? Now, the thing is, in Rapid Miner, you can build your models in three different ways. As I said, you being a more of a domain guy, or doesn't have any coding know-how, still you can work on this data science part. So there are three different, I would say, user profile within Rapid Miner. One is automated data science, which again Rohit will show you these profiles and practically in the demonstration. So automated data science is purely like click based. So you can use auto machine learning to build your machine learning models. Then there is a second approach, which is a visual workflow. So drag and drop. So there are these ready to use operators, but you see, which from this library you can just drag and drop. You can build your workflow or build your models, right? So this is a visual workflow approach. Then third is code based approach as well. So within Rapid Miner, you can even open your codes. You can include your codes like Python, R codes, or you can even open notebooks, compilers as well, and you can write down your codes as well, right? So yeah, these are three different profiles that are exist in Rapid Miner where you can do. And Rapid Miner is a pretty mature product, and for you being students, you got very a lot of advantage with this platform, right? So Rapid Miner is there into the market from past more than say 15 years, 15 years, with more than 1 million users, community members using this platform. There are 4,000 plus universities who are using this platform uh, in their curriculum for analytics, curriculums. There are more than, I would say, 20,000 research citations on RapidMiner that are there, with 40,000 plus organizations using this platform. Right? It's one of the leading data science platform which you can use. There is a very active user community. You can join and you can discuss, you can learn there. Right? So this is RapidMiner. Now, there is a platform called Monarch. If certain data preparation is required, you can use Monarch as well. Then RapidMiner is available both on say on the premise, like you can install on your desktop, on your server and use it, and there is a version available on the cloud as well. Okay. Then once you have built these models, what you can do is you can basically deploy these models machine, because how practically these models will be used. You want to use these models on real-time data. When real-time data starts coming in from your vehicles, you want these models to basically perform or to calculate, predict something which can help you, right? So you deploy these models and you get a lot of visual analytics done, right? So you can monitor, you can get certain reportings and predictions done. So the deployments can done within RapidMiner, and even you can use the deployments in your visualizations. So visualization can be within Altair Panopticon, or say you have other platforms like Tableau, Power BI, where all these can be used. Now Panopticon is a visualization platform where you can build certain nice dashboards, which you can basically see the data, analyze the data, right, and understand what's the data saying to you, right? And this, what I showed earlier, is a dashboard from Panopticon only, right, where you have real time data coming in, right? So you can build this sort of nice dashboards using Panopticon. So now before handing over to Rohit, uh, he'll also talk about this workflow only. So if you start working on a particular project, in data science, there is a standard methodology that you should follow, okay, which we call it as a CRISP DM, or cross industry standard process for data mining. So be it any sort of a use case, you are working on a vehicle sort of a use case, be it a use case from banking industry, they follow the same process. They start with business understanding or the problem understanding. What's the use case I want to do? What is my objective, right? What benefits I want to get out of it, right? Once that is clear, obviously you think of the data part as well, because obviously you need to have the data as well to do data science, right? So you start with data understanding. If the data requires certain preparation, like it is in some semi-structured form which cannot be ready to use, so you need certain data preparation. Once the data is prepared, you start trying out different type of machine learning models. You start building machine learning models for those. Okay, say you want to build a model to uh, predict or show you how your battery life is degrading over the period of time, right? So and to build certain models. So these models could be right from very simple linear regression models to very advanced deep learning neural network models as well, right? Then you evaluate these models, you validate those models, compare different models, and once you are assured, yes, I am getting a nice prediction accuracy with these models, you can go ahead with deployment. What do you mean by deployment is using these models to actually work for you day in day out on the task what you want these models to perform, right? You want to do certain predictions, so these models should do those predictions for you, right? So this is how the workflow would be, and it's a evolving process. These models should get retrained every now and then, so that they also understand how the data is changing, what new is coming, right? And your models are retrained every time. So this will be the workflow, and kind of tell you in a practical scenario this data science workflow. Say with a use case in a visual manner. Say you are developing certain say motors, right? So you want a particular say you have a requirement from the motor that it should generate this much of torque, right? That is the requirement. Now what you can do is, to achieve that objective, obviously you play with the design of the motor. Maybe certain magnet related design parameter dimensions of the rotor status and all those things, right? So you end up doing a lot of simulations, a lot of prototyping or virtual testing with these various designs. And with that, you may have gathered a lot of data with you, right? Like you may have changed the slot depth, slot opening, or various these things of your motor, say magnets. And what you are getting with these design changes is you start getting different sort of a torque that is there, right? So with that, you gather a lot of data, right? So with that data, what I can do is, with that data, I can analyze that data, understand that data, and maybe what I can do is, I want to build a model which should predict the torque for me if I give these these design parameters to that model, that machine learning model, right? So I start building my models. I start comparing different sort of machine learning models, which one is performing better for me, and I basically evaluate those models as well. And once I'm satisfied, I finally go for deployment, right? So I use that model for prediction. So rapid miner can give you this sort of a say predictor simulator where I can play with these design variables, right? And I can see how my torque is changing. So this is all based on the intelligence of the machine learning model which I have trained, right? So now I need not to do every time certain design iterations, actual simulations. I can get some quick insight from this as well, right? So, and even I can deploy this model in Panopticon, which I was showing to you, and you can have this sort of a custom dashboard developed for you, which you can open in any browser, right? And simply what I can do is, I can change certain design variables like slot depth, slot opening, and I can say click to predict, and it should predict the torque for me, right? So that way I can do this whole task using rapid manner, right? So now this same thing can be done for a different sort of a. This was more on the design data. Now say suppose vehicle data, you have a lot of battery data that is coming from the vehicle, right? And that is a very essential part of any vehicle nowadays, like electric vehicles for that matter, right? And you want to build certain models which can help you to analyze the battery performance and all, right? So again, you can analyze the data, you can understand how the charging cycle is happening, what is the life, current, voltage. You can build some machine learning models to find out the remaining useful life of your batteries, right? You can deploy these machine learning models in real time to do those real time calculations for your battery health, right? And you can basically, from the vehicles, you may be getting this sort of a data like ambient temperature, voltage measured, current measured, all these things. And using this different data, I can do is, I can build certain machine learning based models which can help in the uh, predicting the life of the battery, the remaining useful life or the state of the health of the battery, right? So with that, I'll say I'll hand over to Rohit, who will demonstrate rapid miner, how you can build these intelligent models within rapid miner to help you to do certain predictions, right? uh, Rohit, uh, I'll
Yes.
just pause my screen. You can basically uh, start sharing your screen. Okay, I'll stop sharing. Yeah.
Yeah. Thank you. Thank you for the presentation, Sandeep. Uh, let me just share my screen. Yeah. Okay. So can I get a confirmation that my screen is visible to all?
Yes, Rohit, you can see your screen.
Yeah. Thank you. Yeah. So first of all, I'll just give you a quick walkthrough of our data analytics platform, that is RapidMiner. What all are the functions that are available in this platform, and then I'll show you a use case where we'll be trying to model the degradation profile of batteries, right? So so whenever you so this is the RapidMiner landing page. Okay, so so here we have like different personas, like you can build a visual workflow for predicting something manually, or you can make use of the auto model or the turbo prep functionalities, which will help you in cleaning your data and building some models on top of it with without any single line of code, right? So here you can see in RapidMiner we have like different templates to start with. Okay, you can have like predictive maintenance template, or you have sentiment analysis, or a time series forecasting, outlier detection. So these are like pre-built template which you can use and take help from it and build your own process out of it. Okay, so I'll just close it. Okay, so this is the when you create a new blank process. So process is basically where you build your the workflow, right? So in the center, the white space that you see, this is the your space where you will be building your visual workflow with the help of certain building blocks. So those building blocks are basically called as operators in RapidMiner. Okay, so if I just come to the lower left hand side of my platform, so here we have the operator section, and the operator sections are categorized based on its features. So for example, we have data access. Okay, so we have different features for accessing, or different operators for accessing different kind of data. So if you want to read a CSV file, you will make use of a read CSV file operator. Or if you want to read a Excel file, you'll be making use of read Excel file. Okay, and we can, if you have a database, you can connect to a database as well. Or if you have some data stored on cloud, then you can make use of these connectors. Basically, you can read from Amazon S3 storage, Azure cloud, or Google Drive or Google storage. Okay, and each of the operators has certain settings or parameters that you can change. So for example, I want to read a CSV file. So what I'll do is that I'll just left click and drag and drop into the white space in between. Okay, and if I come to the right hand side of my platform, you will see the parameters. Now each operators has different set of parameters, right? So here, if you want to read a CSV file, first I'll have to locate where it is from the locator. Okay, so and we have like different column separators. Okay, you can define those. If you want to skip some command, you can define the what will be the starting rows. Okay, so date format and all. So in this way, like every operator or building block can be configured as per your requirement. Okay, next, after you have accessed your data, you want to maybe do some data cleaning processes. Okay, so for example, you can normalize your data, or scale your values, data values by some weights. Okay, you can do some missing value manipulations, replace some missing values or impute some missing values. For all those, we have like different operators. And maybe coming to the modeling part. Okay, So depending on the use case that you are working upon, you may be having like different operators that could come handy. For example, you are working on some regression based problems. So we have like different regression models available. Okay, so decision tree is one of those, gradient boosted trees. Okay, and if you are working on some classification problem where you want to predicting certain class like yes or no, then can make use of classification based models. Okay, so for example, logistic regression is one such model which is used for classification tasks. Okay, and for example, these operators, okay, it has some input nodes and some output nodes as well. Okay, it basically takes an input data and does some model training on the data and gives us some outputs. Okay, and if you want to know more about what this operator does, then each operator has a help section. If I come to the lower right hand side, okay, this is the help section, which will tell you that what this operator does, right? And what are its input and output features, as well as the if you see, if I come here, we have parameters. What different parameter means, all those information is provided in the help section. So this will help any new user or a citizen data scientist to configure these operators as per their data. All right, and also most of the operators that are available in RapidMiner has a tutorial process. So for example, I want to see how to configure this logistic regression operator. I'll just go to the tutorial process. Okay, I'll just come here. So we'll have some data, and you can see how logistic regression model is being configured. Okay, so I can take help from these processes and build my own process on the data that I have. Right. So this is all from the when you are trying to build a workflow on the from manual side. Okay, but apart from this also we have sorry. Okay, I'll just expand it here. Yes. So apart from your manual process, you also have some automated processes that you can make use of. Okay, so if you see here, we have turbo preparation and auto model. Okay, if I just come for turbo preparation, so this feature is used for data cleaning. Okay, so you'll be having some simple options using which you can clean your data. Okay, and also here you will be having like different exploratory data analysis features also. So for example, if I just click on capacity, I just do a right click and I click on show details. So I'll have the statistical information of one of the columns. Okay, so the minimum value, the maximum, average, standard deviation. Okay, and similarly for all other features, I can have the statistical information. Also, like what is the missing value, percentage of missing values in the one single column. Okay, so all this statistical analysis I can do from turbo prep, as well as I can create some charts out of it. If I just click on charts, okay, so here we can build different kind of charts. So these kinds of options are available here. So for example, I want to build a line chart. Okay, so I can say what would be my x-axis, maybe let's say time, or let's say cycle. Okay, with respect to cycle, how my capacity is changing. So all those initial exploratory or graphical analysis can be done from here. Okay, in an automated way. This can also be done using a manual way. So okay, and next we have the auto model part. Okay, where we'll be trying to load our data and then train it using some of the models that are available on RapidMiner. Right. So so this was like the starting some overview of the platform. Okay, I'll just start with the use case that we have today. Okay, so I'll just okay, I have already loaded the data. Okay, so we'll be trying to prepare a degradation model of battery to analyze the performance of battery. So these days, these lithium-ion batteries are very useful as we are rapidly developing the electric vehicles and other electronic components. So analyzing the battery performance beforehand is very useful for a predictive maintenance of the entire components, right? So this is one use case that we'll be discussing today. So I have here experimental data where we have the battery capacity, the voltage measured, current load, voltage load, the time, the date time when the reading was taken. Okay, so these are some of the attributes or the columns that we have for this use case as of now. Okay, so let's start by doing some feature extraction. I already showed you like how we can analyze the data, right? So maybe from here I'll try to create a new feature, okay, which will represent the state of health of my battery. Okay, so state of health is majorly dependent on the capacity, and it represents the current state of the battery and how much performance it can deliver. Okay, and this is an important metric to know if you want to do some predictive maintenance tasks, right? So I'll make use of this capacity column. Okay, so I'll just do first do a right click. Okay, so what we have here is that the maximum capacity of the battery in hand. So that is 1.852. So I'll just try to create a new column based on this capacity column. Okay, so I'll just do a right click. I'll just say transform. One second. I'll say generate. Okay, so here I can create new features out of my current set of features. I'll say SOH, that will represent the state of health, right? So I'll make use of capacity column. So what I'll do is that I'll just left click, drag and drop into the formula section. Okay, divided by the maximum capacity, which was 1.852. Okay, so this is the formula for my new column. I'll say update preview. So a new column will be generated. Okay. Similarly, if you have like some complex function that or a complex formula that you want to apply on certain columns available and create new columns, then you can make use of functions here. Okay, so we have like different functions, right? So you have like logical functions. Okay, you can combine some if-else conditions and create new formulas. Okay, you can do some mathematical functions as well, right? And if you have some text data, then you can also do some text transformation as well. Okay, so so you can create a whole lot of different features from your existing data. Okay, using these functions available. Okay, so I'm here, like if you can see, we have the new column state of health. Okay, I'll say after like I'm confirmed that okay, this is the right feature that I wanted to generate. I'll say commit generate, right? So yeah, here I have my new column. Let's just try to visualize it. Okay, I'll say I want to do a line plot. What column I want to visualize? I'll say state of health. Apply on x-axis. Maybe I want the cycle. Okay, so basically this is the experimental data where the battery was made to degrade during certain life cycles. So you can see the state of health. It is going through some charge and discharge cycle, but eventually it is getting discharged. So this is the degradation profile we'll be trying to model using a machine learning model, right? So I'll just say cancel. Okay. And more things what you can do is that, for example, this date time column. Okay, maybe we can drop this column as well. So for that also I'll do a right click. I'll say transformations and I'll say remove. Okay, so I'll just say apply. Okay, so this column is removed, so it will ask me to commit or not. I'll say commit. Okay, so we have some input set of features now. So this is like some of the data preparation or data pre-processing task that is normally done in a data science project, right? So after I'm done with my data preparation task, maybe I'll go for modeling. So here I'll first walk you through a automated approach, that is the auto model part of rapid miner, right? So I'll just click on model, right? So here I'll be asked like, what is the kind of task I want to do? I want to predict something, or I want to detect some outlier, or I want to create subgroups out of my entire data. So subgroups are called as clusters. So basically I want to predict something here. So I'll just click on predict, and it will ask like what I want to predict. So I'll just say I want to predict the state of health based on certain input features, right? I'll just say next. Okay. So this is a regression based problem. Okay. If it was classification based problem, then you could have converted it into a classification problem from here. I'll say next. So here, this is the feature selection part. Okay. Where our rapid miner suggests you like based on the input set of features, which features can be taken for modeling or not. So basically there are those are represented using three colors, green, red, and yellow. Okay, so green is the set of features that it suggests that yes, they are good enough and can be taken for modeling. Red, it suggests that no, this is as per the quality of the data that it has. We should avoid taking it for modeling. And there are certain columns which are yellow also, which is not here, but based on domain knowledge you can either take it or not, based so that is dependent on the user. Okay, and how these colors are decided. So if I just click on this eye icon, okay, so if I just come down, okay, so based on different parameters here, like the correlation, IDNA, stability, how many missing values are there. So based on these parameters, it decides whether it will be, in which region. Is it red, yellow, or green? And based on that, those, columns can be taken. Okay. So this can be, the information is already available here. I'll just bring it down. I'll just click on next. Okay, so after feature selection comes the modeling part. Okay, so here we have different models available. Okay, so for regression based problems we have around 6 models available, right? And so the working criteria for each of the model is different. Okay, so based on the data, different model can perform differently. Okay, so that's why we when we have the data, we try to train it on different kinds of model and see that which model is able to perform better. And after we have done that, that model can be used for predicting on any new kind of data. Okay, so here, yeah, you have like different models. Okay, and if you want to do any data, processing on top of it before modeling is done, that can also be done. For example, here we have like automated feature selection option. So generally, sometimes what we have is that we have like hundreds and 200s, like many more features. Okay, and we want to know that out of these, many features, which subset of features will be better for modeling part. Okay, or not all features are good enough for machine learning models. So we can do a automated feature selection. So based on the correlation and some heuristic algorithm, it will give you a subset of features that will be optimal for best performing model, right? So that kind of automated feature selection can also be done. Okay, on top of that, we also have like automated feature generation option. Okay, so we can generate a new feature out of any combination of 2 or 3 columns. Okay, which have like better predictive performance. Okay, so if you want to do those kind of manipulations, that can be done using this automated feature generation options, right? So as of now, I'll just deselect them because we have a limited set of features, right? And I'll keep these three models also, because the training time will be more if I use all the models. So after I have selected these models, I'll just say run. Okay, it will take a couple of seconds to complete. Okay, so I think the first model has completed its training. Okay, we can see the performance matrices, right? So what it does is that the data that you have given, it splits it into a 60-40 ratio, trains the data on the 60% of the split, and tests on the another 40% of the percentage of the split, and gives you a performance metrics, right? So every machine learning model or a use case. So here we have regression based use case. So we have root mean squared error, absolute error, relative error, correlation, these performance matrices. Okay, so for example, relative error is one such performance matrix which must be minimized, right? The minimum is the better. And we have correlation. So in correlation, we check what our model predicted and what the actual values are. The more they are correlated, the better it is. So the higher the correlation, the better the model is performing. Okay, so out of all these, okay, for example, generalized linear model, it is giving 4.5%, relative error, deep learning 0.7, decision 3.6, right? So maybe if I go to deep learning, okay, so I can go to performance. So all my performance matrices will be listed here, right? I can also go to prediction chart. Okay, no more predictions. Maybe I'll just come here. Model simulator performance. Okay. So every model will also give you a simulator. Okay. So for example, here in generalized linear model, okay, we have the simulator. Okay. So we can, if I want to analyze, like if I change my input loads or input features, then how my predictions will vary. So all those things can be done here. So if I just say change this, so you can see my prediction is changing, right? Voltage measured is changing, right? So and here the important factors which are responsible for certain prediction will be given, right? And based on its correlation, whether it is positively impacting my performance or negatively impacting my prediction, the color coding will be done. So for example, for predicting this SOH, my voltage load, current load, and time are positively impacting my predictions, and voltage measured is negatively impacting my predictions, right? So these informations are available here. And also in certain use cases, we have, we want to optimize certain function. Okay, so maybe here I want to, maximize my state of health. So you have this optimize function also available. If I click on optimize, okay, so like either we want to maximize or minimize, okay, that can be done. So maybe I want to maximize. I'll click on next. Okay, so here I need to define the boundary conditions, right? So whether to stay within certain range or standard deviation that I can give. Okay, what the input features that we have. Okay, what could be the range of those input features, that also we can give, or we can also give some constant attributes also, or columns also. Okay, next I'll click on next. Okay, here based on time, right, whether you allow it to go for many iterations. So you can select no limit, or you want to give a time limit, that can be done. I'll just say run. Okay, it will run optimization algorithm. I'll say finish, and it will give me the optimum set of input features that will result in the maximum state of health. Okay, so so these things can be done here from auto model. Okay, if I just come here to overview, right? So also you can save the results and the model as well. And based on performance, for example, if I decide that okay, my deep learning model is performing well, I may use it for deployment purposes, right? So here in the left hand side, we have the save results options. I'll click on save results, and yeah, Here I'll say auto model SOH results. Right. Let's click on OK. So all my model results will be stored. So I just come to battery RUL SOH. Okay. So we trained 3 models, right? Decision tree, deep learning, generalized linear model. So all those will be available. Okay. If I just open any of the yes. So every algorithm will be having a model. So for example, this is the production model that is generated. Now, if I want to use this for on predicting on a new data, that can be done. Okay. So for example, I'll just click start a new blank process. Okay. I'll bring this production model. Okay. So applying on a new data requires 2 things: the model itself, the data. Okay. Maybe I'll take the data. 1 second. Result. I have some test data. Okay, so you have model, you have data, and you need to apply the model. Okay, so for applying the model also, we have the operator, which is called as apply model. Okay, you can see some recommended operators which is being suggested automatically by RapidMiner based on the workflow that I am designing. Okay, so I'll just bring this apply model. Okay, so it has like 2 input ports. One expects the model, second expects the data. Okay, so I'll drag and drop, connect the input nodes. I'll say, so an output port, we have 2 things. One is the data, okay, that is the predicted data, and the model itself. Okay, and here we have the results port. The results of your workflow will be generated at the results port. Right, I'll just click run. So here we have the prediction columns, right? Okay, so in this way you can once your model is done, you can apply on a new data. Okay, so this was the automated approach. So maybe I'll just walk you through a manual approach that we have prepared. Okay, so let me just expand. Okay. Okay. So this is the workflow, okay, which we have created manually for predicting the state of health of battery. Okay. So first of all, we are loading a data. Okay, our training data. And if I just show you what is the training data, so what I can do is that after this, data is loaded, I can stop my process and see the intermediate results. So I can do a breakpoint. So maybe I'll just do a breakpoint after. So my process will stop just after this operator has loaded the data. I'll say run. Okay. So this is the data that we have that we used for creating this manual workflow. Okay, so we have a couple of new columns also, like temperature, right? Temperature measured, remaining useful life, and state of health, right? Okay, so once I have done like loading the data, okay, we are doing some feature selection options. Okay, so here using this operator like select attributes. So the columns in RapidMiner are basically called attributes. So I can select and deselect some of the columns, right? So here, what I'm doing is that I'm deselecting some of the columns, right, and keeping these as my input features and my output features. That is the SOH. I'll say cancel. Okay. Next important thing, in building any predictive process in RapidMiner is setting the rule. So your RapidMiners could know that what is the column that you want to predict and what are the other features that will be used as independent set of features for predicting a particular attributes. Okay, so we have basically the feature that we want to predict, those are called as labels. Okay, so we give the attribute name. So if I just do click here, we will be having a drop down. Okay, so which column we want to select? We want to select SOH, and we want to give a particular role to it. So the column that we want to predict, it is set as a label, right? So I'll click on label, apply. Okay, let me come to this later. I'll just go inside. So this is a sub process basically. I'll just come inside. Okay, so here we are training one model that is a gradient boosted tree. Okay, and we have like different parameters here of that. Okay, so the data is getting splitted into two parts. Okay, one part is being used for training, and second part is used for testing. Okay, so we are applying the model and testing the performance, right? What we are measuring, we are measuring some root mean squared error, relative error, these performance matrices that we also saw in the auto model part. Okay, and one more important thing here is that during modeling, right, every model will be having some parameters. Okay, and the behavior of the model will change based on the parameter values. Okay, so for example, so here we have, this is a tree based model. We have one parameter which says what would be the number of trees. Okay, so if it is set to 50, then it will give certain predictions. If I set it to 100, the predictions may change, right? Okay, but there will be some optimal value of these parameters that will give you the maximum performance, right? To attain that optimal parameter value, we do some optimization, right? So for that also we have one operator which is called as optimize parameters, right? So inside this we put our model, okay, and we change the parameters of this operator. If I just come here, okay, so here we can see we are trying to optimize three parameters, that is the number of trees, maximal depth, and learning rate. So automatically this operator will try different combinations from the values that we have given here. Okay, and out of these, what the subset of parameter values which gives the optimal performance, that will be applied on the model, and the model will be generated, right? So this is how a model is getting trained here, right? And once we have our trained model, okay, we are applying it on a test data. Okay, so we are again loading our data. We are creating some column, deselecting some columns, setting the role, applying the model and all, right? So if I just run this process, it might take a few seconds. Okay, so this is the optimization that has been happening. Okay, so these are the results, right? The predicted data, the performance metrics. Okay, and these are the results of my optimization algorithm that just ran. Okay, so if I just come to my performance matrices, okay, so I can see a good correlation, lower relative error. Okay, so and these are my this is my actual and this is my predicted values. If I can just visualize them as well, I can do a line chart. I'll say SOH versus prediction SOH, say apply. Okay, and here maybe, okay, I'll keep it like that. Okay, so here we can see how my actual and predicted values are performing. Okay, so we have like a similar pattern being observed. Okay, so both for prediction, predicted, and actual values, right? So once we have trained and tested your models on Rapid Miner Studio platform, you can next go to deployment, right? So I just come and show you our deployment platform. Okay, so we have this Rapid Miner AI Hub. Okay, so this is basically used for deployment or deploying your models onto a cloud platform. Okay, and then API or a REST endpoint can be generated from your deployment, and which can be later integrated into any other third-party applications. Like I'll just show you that we have integrated it onto our dashboarding platform, that is Panopticon. Okay, so what you can do is that we have this concept of projects here. Okay, you can upload whatever projects you create here, right? We have created this process here, right? So we can upload these processes onto our AI hub, okay, and generate some endpoints. If I just click on endpoints, it's loading, right? So we have different endpoints that is getting generated, right? So these are basically APIs, right? So these APIs can then be integrated with our Panopticon dashboard. So we have prepared some Pano dashboards that I'll just demonstrate. Okay, so this is let me just reload. Okay, so this is like one of the dashboards. Okay, so where you can live stream your data, right, and have your predictions at the real time. Okay, so here we are trying to predict the remaining useful life based on some input data, and we are also showcasing what are the input set of features, right? And so maybe. And we have like another set of dashboards that you can prepare where you can have your user input the values for some input features, okay, and get the prediction out of it. Okay, so for example, here I want to change the capacity and some input features. I'll click on predict, okay, and I'll get some predicted values out of it. Okay, so in many use cases, this is also the scenario where user wants to try based on different input values what is the prediction that they are getting from their models, right? So basically what we have done here is that if I just click on edit, okay, if I just go to work, so here we create a backend actions. Hello.
Yeah, your screen.
Hello, is there any question from anyone?
So your screen is stuck.
Okay. Let me reshare. Is my screen visible?
Yes, sir.
Yeah, thank you. Yeah. So what I was covering is that integrating our REST endpoint generated from AI Hub onto our deployment platform. So this is the some of the configurations that we do at the backend. So this is the REST endpoint like that we get from AI Hub. Okay. So this we integrate here. Okay. We provide some authentication and we pass some data. Okay. This data in this use case, we are getting it from the user. So once the user gives the input values, we pass it to our REST endpoint and it gives back the prediction, right? So these kind of different dashboard for different use cases can be built. Okay, and this is what the end user will consume, right? So this was it from my side on the RapidMiner platform and how you can do some modeling on it, visualize the data and the deployment parts. Right. So maybe we'll take up some questions now, or I'll just stop my sharing as of now.
Okay. Yeah, Rohit, I'll just finish with the learning platform part, and then maybe we'll take up the question, right? So let me just again reshare my screen. And, yeah. Rohit, just confirm if you can see my screen.
Yes, yes, I can see.
Okay, great. So yeah, so that was rapid miner demonstration from Rohit, right? So as I said, rapid miner. So you can build your model and then you can deploy them as well, and you can build these nice dashboards using Panopticon, right? So you can see one of the practical case here from one of our customer who's into car racing analytics, right? So they again get this data, real time data, streaming data, and they do a lot of analytics over this data, right? So like in race and post race analysis, visualization of the data, drilling down into various functions of the car, race performance, driver behavior, right? And then finding out, even identifying the pattern as well, and wherever those potential failure may happen, right? Identifying some of the outliers. So these are some of the applications they have been using, right? So if you sort of see this testimonial from this particular customer who ProDrive, who into more of a car racing, right? So they get all these real time data from their vehicles, and then basically they do sort of analytics using all their data analytics platforms, right? You can see various dashboard like wheel speed, telemetry data, all different sort of dashboard, and they analyze the data in real time. Right? So this was on the platform and the applications. Now, obviously, you will want to learn this platform if you want to use it for your applications. So there is a very nice platform that is available for you where you can learn Rapid Miner. So we call it as Rapid Miner Learning Academy. So you have to go to academy.rapidminer.com. There you have very well structured and well curated content, learning content and teaching content with proper modules, exercises, video tutorials, example data, which covers all of the topics that are there, right? So once you go to this is a landing page where you can get started with the learning. You can basically go through the libraries, content library, what all content is there. Good part is even you can do some certifications, digital certification. Once you go through the course content, you can do some gold certifications, right? Which you will get some digital badges which you can post on your profiles as well, right? Once you go into get started, you'll get structured learning content. You can go from get started to applications to machine learning to the advanced sections, right? And you in each sections you have videos and tutorials to go through, right? So these are various learning paths that are available. Getting started with rapid miner and machine learning, you should start from here, and then applications and use cases, right? Then go into slightly advanced topics, right? And when you browse the content, you can browse it by various phases in a data science at your based on your experience level or what kind of profile you have, and you will find all those learning content. You can browse through. If you remember, I showed you the Chris DM workflow, how it works, right? So our certification also is based on this workflow only. So you start from here, and you basically start doing these certifications, and at the end you becomes an expert, right, with this complete workflow. So, right? So these certifications, you can basically, after doing the courses, you can opt for any of these exams. These will be done online only on this portal only, uh, within your browser. And once done, you basically pass that exam, you get the certification digital badges, which you can post on your LinkedIn profiles and all, right? And as I said, these certifications are based on certain different user persona and different levels. Like these are the master or the, I would say, basic level, and then you get the professional levels as well, right? And last but not least, you will get a use case gold mine uh, page as well, where you'll find some practical use cases which other users have developed and they have posted. So even you can contribute here, or you can get the benefit from these use cases, right? So this is the academy. Then you have a user community as well, which is very strong user community. You have to go to uh, community.rapidminer.com and you'll end up here. Here you can see there are almost 1.2 million users of RapidMiner. They basically network here. So you can post your questions. You can browse through chat history or content, what all people have posted, right? So there are high chances whatever the queries you have, they may be answered, already here, right? So this was about our platforms. As you have seen, using Altair data analytics and digital twin platform, you can connect to any sort of a data. You can process the data. You can do real-time analytics. You can build certain predictive models like how Rohit have shown you. You can do certain data visualization and everything without using any code, right? No code way, right? And then even you can develop certain digital twin models as well, be it physics driven twin using Altair Activate or using data driven twin, how we have shown. And there can be an integration that can also happen, right? So this was all about this session. Let me just give you a glimpse of next sessions that are planned. So there is a next session that is planned on emag communication connectivity, which is on September 6th. Virtual drive tests, ADAS sensors, communication antennas, designing them, or placement of those antennas, doing those electromagnetic studies, doing the virtual drive tests, right? So these are there with Altair as well. So this is planned. And another session which is planned on 8th of September, which is on embedded system design using Altair Embed. So here Altair Embed plus Open Vision you can use for image and video processing, right? So where all you can basically simulate various scenarios, like your lane detection, tracking, and even object and vehicle detection, sort of use cases also you can do. So these are the two next sessions which definitely should join, right? Lastly, just for your reference, you can even take a snapshot of this slide. This is Formula Bharat, and Altair academic initiatives, and some of the information that you should be aware of, right? And some of the contact details. So feel free to take a snapshot of this, right? That's it from our side for this session. We are open for any questions that are there from you. We'll be happy to answer those, right? Feel free to post it in the chat. We can connect as well later on if it's required. Yeah. Thanks. Thank you all.
Well, now, thank you so much, Sandeep. I will now be ready to answer your queries, if any, pertaining to today's topic.